Hello friends, let us now take the dot product and cross product of unit vectors I, j and k. Okay, first let us see the dot product of I and I mean I dot I. You all know A dot B is mod A mod B cos theta where theta is angle between A and B. Okay, this is A dot B. Fine. Now you all know I is a unit vector along positive x direction. So angle between this I and another I is obviously 0 because they are parallel vectors. In fact, they are equal vectors. Now I dot I will be obviously mod I cos 0 because angle between I and I is 0 degree. I is a unit vector, so mod I is going to be 1 and cos 0 is also 1. So I dot I is 1. Okay. So similarly, we can easily show that I dot I is equal to j dot j equal to k dot k equal to 1. Okay. So I, j, j, k, k is 1 in dot product. Fine. Like basically when you are trying to compute dot product of two vectors which are written in terms of I, j, k. For example, suppose A is a vector ai plus bj plus ck. And another vector you have B which is xi plus yj and zk. Now what is going to be A dot B? I mean how many terms you are going to have there. This just I want to show you how many terms you are going to get over here. Out of that how many terms are going to be not 0, how many terms are going to be 0. So let's take A dot B. It's going to be ai plus bj plus ck dot xi plus yj plus zk. Now you know here if you go by simple multiplication type, this dot this, then this dot this, then this dot this, you have three terms, right? Then again when you take up this B, this dot this, this dot this and this dot this, three more terms. Finally you have three more terms over here, this dot this, this dot this, this dot this. So you have 9 terms, but out of this 9 terms you can easily show that only these 3 terms, I mean I with I, only I with I means I need to take only this term in fact. Okay, other two I need not take because that's not going to exist, it will be 0, we will show that. Okay, similarly only j with j term will remain because j dot j is again 1, j dot j is 1 and k dot k is 1, so even this one term will remain. So only these 3 terms. Okay, I dot I term, j dot j terms means I should write here, this is j dot j over here. Okay, sorry. So I dot I term will remain, j dot j term will remain and k dot k term will remain. All other terms will vanish. So only 3 terms are non-zero and other 6 terms will just vanish or they are 0. I'll show you why, because I mean in fact you all can tell without me showing there, but still let me show it. I dot I, j dot j, k dot k is 1. Then what about I dot j? You know very well dot product or scalar product of perpendicular vectors is 0. I, j, k are all mutually perpendicular vectors. I, j, k is out with the board towards you. So dot product obviously this is mod I mod j cos 90. Angle between I and j is what? 90 degree. Okay. So obviously this is 90 degree. So I dot j mod I mod j cos 90. Cos 90 is 0. So all these terms I, j, j, k, I mean then k, I, j, j, k, k, I, then reverse of this. I mean I dot j means even j dot I. We know it very well. A dot b is b dot a. Dot product or scalar product is commutative. So I dot j can also be written as j dot I. So even that is 0. Then you need to take j dot k means then k dot j. That is also 0. Then k dot I is 0 means I dot k also has to be 0. So all the 6 terms are 0. Only I, jj and kk are 1. I mean dot product. So you need to take only I with I term, j with j term and k with k term. So basically when you try to take the scalar product over here, what are you going to get? So this ai dot xi, okay, so only ii term, then jj term. Straight away you can take j term now, okay, this dot this is going to be bj dot yj, and then the ck dot zk, okay, ck dot zk. So this is going to be the scalar product in this case. If a and b are these two vectors, then a dot b or scalar product of a and b is going to be this. But again, then you know very well what happens here. Let us check it out. I dot I is 1, so this becomes ax into I dot I is 1. So let me write it as ax plus here by, j dot j is 1, so by into 1 is by, plus cz, k dot k is 1, so here cz into 1 is cz, okay. So this is the dot product of a and b, that is ax plus by plus cz, that is, okay, ax plus by plus cz, okay, that is a dot b. I dot I is 1, j dot j is 1, k dot k is 1, so we are taking only I with I, j with j and k with k while dotting. Others will become 0, so we are not even considering that. Fine. So simple to get the dot product, okay. So I dot I, j dot j, k dot k is 1, all others are 0 here. I, j, k are all mutually perpendicular, so I dot j, j dot k, k dot I, or then I dot j is 0 means j dot I also will be 0 because dot product is commutative. That way the other 3 also will be 0. Fine. Let's consider a few examples over here, at least one example. Suppose A is a vector, say I plus 2j minus 3k. I'm just randomly picking out the numbers, and B is 2i minus 3j plus 4k. Now what about A dot B? Okay, so it's quite simple. You all know by this time only I, j, j, k, k are 1. All others are 0 when you are taking dot, so you need to dot only I with I, j with j and k with k, okay. Here it's I means 1i, 1 into 2, 2, I dot I is 1, then this 2 into minus 3 is minus 6, j dot j is 1, okay, minus 6 into 1 is obviously minus 6, fine. Similarly now this minus 3 into 4 is minus 12, k dot k is 1, so this is the answer over here. In fact this is minus 18 plus 2 is going to be minus 16, okay. A dot B is minus 16, fine, something like this. Whatever units here, accordingly you can adjust the units over here, fine. Like for example, if this is say force and this is say displacement, then F dot S is going to be, A dot B becomes F dot S, which is work, so this is going to be joules. If this force is in newtons and this is in meters, this is going to be in joules, okay. So anyway, forget about the numbers. Right now we are just bothered about the mathematical part over here, not the physics part, okay. So anyway, all this we are going to learn in different chapters, particularly in work power energy. Even in this chapter we are going to do plenty of problems and you get a lot of good practice, okay. Now consider the cross product of unit vectors I, j, k. We know I, j, k are mutually perpendicular. Just see I cross I is what? We have already seen I dot I is j dot j is k dot k is equal to 1, okay. This should be j. So this we have already seen. I dot I, j dot j, k dot k is 1. Now let us see what about the cross product. First of all, we know cross product is a vector. So we need to first find out its magnitude. First let us try to find out the magnitude of I cross I. You know mod I sin theta, okay, sin 0 because angle between I and I is 0, I and I. So mod I, unit vector, I is a unit vector, mod I is 1 into 1, sin 0 is 0, something into 0 obviously 0. So mod I cross I is 0. That means we now know I cross I is a null vector, j cross j will also be a null vector, and k cross k will also be a null vector, okay. So I cross I equal to j cross j equal to k cross k is 0. So these are null vectors, fine. That means when you are computing dot product between unit vectors I, j, k, only I, j, j, k, k are 1 and other 6 terms were 0. here 3 terms are 0 and other 6 terms won't be 0. Let us check out what will be the value of I cross j. Please listen this carefully and try to understand conceptually. Okay, no need to cram up. Fine. What is mod I cross j? You know very well I cross j is a vector, so it should have magnitude as well as direction. First, let's find out the magnitude. So you know very well a mod of a cross b is mod a mod b sin theta. So that's what we are going to use now, where theta is angle between vectors a and b. Fine. Now what is mod a? Mod I. So this can be written as mod I. Okay, a cross b, like mod a mod b. Mod b becomes mod j in this case, sin theta. What is the angle between ij and k? We know very well ij k are all mutually perpendicular. So angle between ij or jk or ki is 90 degrees. This is I towards positive x direction, and this is unit vector j towards positive y direction. This is j. So you have I cross k we need to compute. Angle is 90 degree between I and j. So here sin 90. Okay, what is the value of this particular whole term? Mod I is 1, mod j is 1, ij being unit vector, sin 90 is also 1, this is 1. That means mod I cross j is 1 means I cross j is a unit vector. Clear? I cross j is a unit vector, that's for sure. I mean mod I cross j is 1 means its magnitude is 1 means I cross j is a unit vector. Fine? And now what about its direction? How to get the direction? You already know very well. If suppose A is a vector in the plane of the board here and B is another vector in the same plane I am taking for convenience, this is theta. A cross B, anti-out, it's going to be out of the board towards you, out of the board towards you. A cross B perpendicular to the plane of the board, out of the board. Okay? See, we know I cross j is a vector. Okay, so I cross j should have both magnitude as well as direction. We already got the magnitude of I cross j as 1. So I cross j is a unit vector because its magnitude is 1. Now let us try to get the direction of I cross j. You know I is towards positive x direction and j is towards positive y direction. How to get the direction of I cross j? You already know how to get the direction of A cross B. If A and B are in the plane of the board as shown here, A and B, A cross B is anti-clockwise out of the board towards you. Okay, so over here as you are able to see, I and J, I cross J means rotate vector I towards J in this direction, that is anti-clockwise means out of the board. Okay, anti-out, anti-clock means out of the board towards you, that means towards positive Z direction. Clear? So I cross j is a unit vector because its magnitude is 1. So I cross j is a unit vector and it is towards positive z direction. And you already know, what do you say a unit vector towards positive z direction? What do you denote it by? Obviously k. Okay, so I cross j is a unit vector towards positive z direction. Unit vector towards positive z direction is nothing but k. So I cross j is k. Okay, so using this way you can show that I cross j is k, and you already shown this. Okay, similarly we can show that j cross ij jk, j cross k is I, ij jk ki, k cross I is going to be j. Okay, and we already know if A and B are vectors in the plane of the board here as shown in the figure, A cross B is out of the board and B cross A is into the board. A cross B and B cross A are negative vectors of each other. A cross B is negative vector of B cross A. Okay, so using that concept we can easily show that when I cross j is k, definitely j cross I is going to be minus k. Okay, because cross product is anti-commutative, it's not commutative. I cross j is k means j cross I is going to be minus k. Fine, because A cross B and B cross A are negative vectors of each other. We know I cross j is out of the board, j cross I is going to be into the board, that means minus k towards negative z direction. Similarly j cross k is I means k cross j is going to be minus I, and similarly k cross I is j means I cross k is going to be minus j. Okay, so one thing is clear, the 6 terms are not going to be 0, only 3 terms are going to be 0 when you are computing cross product. I, j, j, k, k is 0, cross dots I, j, j, k, k is 1. Okay, and I cross j is k. It's not 1 or 0 because cross product is a vector itself. I and j are unit vectors. No doubt I cross j, its magnitude is 1. So I cross j or j cross k, k cross a, all these are unit vectors. In fact, I mean I cross j, j cross k, k cross I. Of course, if these are unit vectors, their negative vectors are also going to be unit vectors. Clear? So they are unit vectors, but they are vectors. I cross j, anti-out, it's k, j cross I into the board, minus k, something like that. Fine? Anyway, you need not remember all these things, 6 terms. What you can do is, you can just draw an anti-clockwise cycle and then you can remember a simple relationship. Like what you can do is, suppose this is I, write down j somewhere here and k somewhere here. Okay? I, j, k in anti-clock direction. Now, just let me join them in an anti-clock direction like this. Anti-clock direction is taken as positive, so I am joining like this. Now you know very well, Ij will be k, I mean cross. See, Ij is k, I cross j is k, I cross j is k. Okay, now j cross k is I, j cross k is I, Ij is k, jk is I, k cross I is j, k cross I is j. Okay, so when you are going anti-clock, just tell positive, and when you are going clockwise, just tell negatives. I mean, you can do like this, I cross j is k, I cross j is k, Ij is k, jk is I, jk is I, and ki is j. We are going anti-clockwise, so I am just telling positive. J cross I is, you know, what is that? K cross I is j. And when you go clockwise, just take the negative things. I mean, if you go this way, okay, like if you go this way, then you need to take negative. I cross k, it's going to be, I cross k is going to be minus j, because I am going clockwise now. Fine. Similarly, kj will be, k cross j will be minus I. Okay, j cross I will be minus k, something like that. It's clear? You can even see from here itself. See, I cross j is k, Ij is k, ji will be minus k. We go clockwise till minus j cross I will be minus k. J cross I is negative of this, so it will be minus k. So just remember this. Fine. So if you go anti-clockwise, write down like this: I, j, k. I cross j, k. J cross k, I. K cross I, j. And then when you go clockwise, negatives: j cross I minus k, I cross k minus j, k cross j minus I. Clear? Let us take a simple example of computing a cross product involving ijk, I mean vectors involving ijk. Suppose vector A is represented as ai plus bj plus ck, and vector B is written as xi plus yj plus zk. What about A cross B now? Fine. A cross B. So let me write here. It's going to be all this cross xi plus yj plus zk. Okay. Now, if you do in a systematic way, then you need to consider the 6 terms. 3 terms are 0, you know very well. I cross I, j cross j, k cross k is 0 or null vector. So here you should not take I with I, you should not take j with j, because that's going to be 0, and even k cross k will be 0. These 3 terms we are not going to take. So we are going to take other 6 terms. Okay. Altogether you will have 9 terms. These are 3 into 3 will be 9 terms, but we need to take only 6 terms. Fine. So we are not going to take I with I. So let us take I with j and I with k. Okay, only two terms. I with jk, j with k and I, and k with I and j, something like that. Okay. So now what is going to be ai, this ai cross yj. Okay. Next plus this ai cross this term. Okay, we are not taking ai cross xi because I cross I is 0, we know that, fine. So then this same ai cross this term I'm doing in a very systematic and step by step fashion. Now let me take this other term bj. So bj cross xi, because j cross I is not 0, only j cross j is 0, fine. So bj cross xi, and one more term here bj cross, this one I need to take now, bj cross this term. Okay, so let me use a different color here. Okay, so bj cross zk. Then two more terms over here, plus ck cross xi and ck cross yj. Okay, this cross this and this cross this. We know k cross k is 0, so ck cross zk I am not taking, fine. Now when you try to solve this, ay as it is, what about ij, I cross j? You can check out here, ij is k, so I can write down k for I cross j. Okay, now az as it is, I'm writing as it is az. Then I cross k, I need I cross k, k cross I is j, I cross k is minus j. So for this part is over. So for I cross k I need to write minus j. Okay, from here see, I cross k is minus j, we know k cross I is j, fine. Now over here bx, let me write plus bx as it is. Now j cross I, we know very well I cross j is k, so j cross I is going to be minus k, j cross I is minus k, so again here I need to write negative value. Okay, I have considered this part. Now let us take this part. Here bz plus bz as it is. Now j cross k is I, so I need to write I straight away. Then plus this term cx as it is. Then k cross I is j, so I need not write parenthesis or bracket here, straight away let me write plus j. Okay, see, k cross I, cx as it is, and k cross I is j. Then one more term left out, because we need 6 terms. See, 1 2 3 4 5, one more term, because other 3 terms are 0 anyway, I, j, j, k, k, cross part, fine. Now last part, this one, cy as it is, and then k cross j, j cross k is I, k cross j will be minus I, k cross j is minus I, so this is minus I. Okay, this all stuff, doing everything in a very step by step way, you get this, fine. This is basically nothing but a cross b, fine, where a is this particular vector and b is this particular vector. A cross b is finally, you have, let's write first I term, then j term, then k term. Here I term, and here is also you have I term, fine. Let me take I common here. Okay, if I take I common, within bracket you have here what, bz minus cy. Okay, so bz minus cy, then plus j, let me take common. Okay, these two terms already over, j terms over here, and next is here. So j, when it's common out, cx is left out here, cx, and here minus az. Okay, minus az, and then plus k term, let me take out from here and here. K is out means ay, and here minus bx, so ay minus bx. Okay, so this is the cross product of a and b, or this is the vector a cross b. Okay, of course we are taking in symbolic form, I mean A, B, C or X, Y, Z. That's why you're getting a bit complex. Maybe if it's numerical, you can get it much easier. But then this is not a very easy approach to get the value of A cross B. You can do in much simpler way using determinants. Okay, this is a very systematic approach using the basic idea of I cross J is K, J cross K is I. But over here, because we are using six things over here which are normally not written on the book when you are solving this particular problem, so there is a possibility of making a mistake in plus or minus, like instead of taking J cross K as I, if you take up J cross K as minus I, then everything will be gone. Fine, one mistake is enough to spoil the whole show. Fine. So what we can do is determinant method. We will see, you would still end up with the same answer, but that will be much easier. Okay, let us see what is determinant method to get the value of A cross B. Okay, let us find out A cross B using determinant method. We got this answer for A cross B when A and B were these vectors. Okay, so here you need to write I, J, K plus minus plus, and when you need to find out A cross B, write A and then B here. Write the coefficients of I, J, K here. See, coefficient of I is A, so this is B and this is C, coefficient of K. Okay, over here in case of vector B, X, Y and Z are coefficients of I, J, K respectively. So you need to write over here. If any one component is not there, suppose this part is not there, then you can imagine it is 0, K, and you need to write 0 over here. Anyway, after writing this, okay, you just need to write plus minus plus here. Why you are writing this? MPC students can easily understand. It is the minus 1 power I plus j, where it is I throw in j column. Okay, cofactor, sign, something like that. More details you will learn in determinants. Okay, over here right now just remember plus minus plus. Particularly by TC students, you need not worry about how you are getting this plus minus plus, but don't write minus plus minus, just remember plus minus plus. Fine. Now you write down, now we need A cross B. First we are writing A, then B, coefficients over here, plus minus plus I, J, K. Okay, A cross B equal to, first write down plus I. Okay, now forget about the terms below I, forget about these terms. Okay, terms below I, then this into this, that is BK, not K, I think it's quotient of K, this is Z, not K, sorry, it should be Z. So BZ minus this into this, okay, YC. Now minus J into, forget about these terms below, these numbers or terms below J. Now you need to take this into this, AZ minus XC. Okay, then plus K, forget about the terms below K. Now this into this, AY minus XB. Okay, AY minus XB. Okay, if you want to check out this, say I BZ minus YC, I PZ minus CY. Okay, and then minus J AZ minus XC. Here I have not written minus, so I am getting CX minus AZ. Doesn't matter. If I bring this, same thing, like if you want you can write plus here and then it becomes XC minus AZ. Fine, anyway doesn't matter. Okay, if I take minus sign out here, you will have this term ending up as this term. Fine, then this is plus K AY minus XB plus K into AY minus XB or BX, doesn't matter. Fine. Okay. So this is how you use determinants to get the cross product. In fact, this way you will be able to get it much quicker. Let us just take one numerical example so that things will become more easier for you to, okay. Let us now consider one numerical example to how to get A cross B. Here you have given vectors A and B. The equations I have already written, 1, minus 3 and 1, minus 1, 1 and 4, minus 1, 1 and 4. I, J, K, and you already know, you need to remember here plus, minus, plus. And then to get A cross B, what do you do? Plus I, as it is, you need to write down plus I here. Okay, plus I means I itself. Now forget about the numbers below I. Okay, now you need to take this into this. Okay, minus 12 Okay, then you need to write minus here, then you go there, so that it becomes convenience for you. You don't make errors, otherwise you may make mistakes. See, plus I we are writing, then forget about the numbers below I. This into this is minus 12, this into this minus this into this we need to take determinant method, right? So minus this into this is 1. Let me write 1 here as it is. Then minus j I need to write here. Okay. Then forget about the numbers below j. This into this is 4 into 1 is 4 minus. Then you go here. You know, minus 1 into 1 is again minus 1. Minus of minus 1 becomes plus 1. Okay. Okay, for those who have not followed this, I will repeat this once again. Okay. So minus j we are writing. Forget about the numbers below j. This into this 4 minus this into this is again minus 1. That means minus of minus 1. That's why it becomes plus 1 here. And then plus k. Okay. Forget about the numbers below k. This into this is 1. And then minus as it is. Then minus minus we are already writing. This into this minus this into this is again minus 1 into minus 3 is plus 3. So plus 3 as it is. This minus is already, this into this minus this into this. So minus we are already writing, this into this is again plus 3, so that is separate. Fine. So finally what you get? A cross B is minus 13i and minus 5j minus 2k. Okay. So whether you compute using this method or go by systematic approach, this cross this simplifying, and then I cross j is k, j cross k is I, k cross j is minus I, using all that also you would end up with the same answer. Clear? But then those who are comfortable with this determinant method, they don't even have to draw this determinant and write all this stuff. You can directly compute A cross B in much less time, much faster, much shorter technique. So suppose you need A cross B. Okay, so let us straight away try to get A cross B here. A cross B. We need for given vectors A and B. You already know, going by determinant method, I, J, K plus minus plus. This much you can keep in your mind, and then straight away write down plus I, plus minus plus I into I, quotients of I, you forget about this, okay, so this into this, minus 3 into 4, minus 12, minus this into this, 1, quotient of j is 1, 1, okay, 1 into 1 is 1, minus j, plus minus plus, then forget about the quotients of j, then now, quotient of I is 1, 1 into 4 is 4, minus this into this, this is minus 1, quotient of I, and here 1, so minus 1 into 1, obviously minus 1, minus of minus 1, plus 1, and then plus k, plus minus plus. Forget about the k, quotients of k. Now take this into this, quotient of I is 1 and 1 over here, 1 into 1, 1 minus 1 into minus 3 is plus 3, so plus 3 as it is here. So this is nothing but the same answer. Clear? Of course, same technique, we are using the same determinant method, but just we are avoiding the time needed to write all the determinant and all that. Just we are out of memory we are recollecting plus minus plus I, then forget about this. But then you need to write the vectors first A and then B, and then go this way, you get A cross B. If you first write B and then A, you will end up getting B cross A, which will be minus A cross B and not A cross. Okay, obviously if this is A cross B, then what will be B cross A? That will be negative vector of A cross B. B cross A and A cross B are negative vectors of each other. So B cross A is going to be minus of all this is going to be all plus terms here. That is 13I plus 5J and plus 2K. That is going to be B cross A. Is it clear? Let us do some numericals based on the given vectors A and B. What is A dot B here? Dot product means I with I, J with J and K with K, all others are 0. Here see 1 into minus 1, that is minus 1, I dot I is 1, minus 3 into 1, quotients, minus 3 into 1 is minus 3, and then J dot J is 1, 1 into 4 quotients, 1 here, 4 here, 1 into 4, 4 plus 4, so this is 0, dot product is 0, means angle between given two vectors is going to be 90 degree, or these two vectors are mutually perpendicular, because we know very well A dot B is mod A mod B cos theta, okay, and if this is 0, this will be 0 provided these two are not 0, and we know here mod A is not 0, mod B is not 0. What about mod A? Magnitude of vector A, okay, under root here quotient square, I mean xi plus yj plus zk means root x square plus y square plus z square quotient, okay. If a vector is say xi plus or minus yj plus or minus zk, then how will you compute mod A? Root x square plus y square plus z square, okay, plus or minus doesn't matter here, fine. So here 1 squared plus minus 3 squared is again plus 9 only, and then plus 1, this is not 0, definitely root over 11. Similarly mod B is also not 0. Remember, if magnitude of a vector is not 0, it is called a proper vector. I mean a vector which is not null vector is proper vector, fine. So here both A and B are proper vectors, so their mods are not 0, this is not 0, this is not 0, then definitely this has to be 0, cos theta is 0 means theta has to be 90 degree between the two vectors A and B, okay. So here given two vectors are mutually perpendicular, this is mod A, and what about mod B? You can easily compute even that, root over 1 square, I mean minus 1 squared is 1 squared only, fine, and then plus 1 plus 16, that is root over 18, so this is mod B, fine. And if at all you are asked to find the unit vector of vector A or unit vector parallel to vector A, we know unit vector of vector A is A by mod A, fine. So what about A here? That is I minus 3j plus k. This is given vector A by mod A. Mod A we already computed root 11, and therefore this is a vector which is unit vector along A or parallel to A. Means its magnitude, if you compute the magnitude of this vector, I mean mod of this, okay, or mod of this is going to be definitely 1, and its direction will be same as the direction of vector A, okay. And what about unit vector of vector B? It will be B cap, so B by mod B, fine. Vector B is here minus I plus j plus 4k, this is the given vector B by, okay, mod B is root 18, so let me write root 18 over here, fine. So this is unit vector of vector B, or a vector whose magnitude is 1 and direction is same as that of B. Unit vector is just used as a direction indicator, okay. Suppose if I am asking you to compute a vector whose magnitude is same as that of A, magnitude is same as that of vector A means mod A like magnitude, and direction is same as that of B, then it is going to be this. Mod A will give you magnitude of A, B cap will give you direction of B. So what will be that vector? So it will be mod A is what? I think we have computed mod A, which is root 11. So let me write root 11, and B cap, direction of B is B cap, which is this whole stuff, unit vector of B. Let me write that. It is minus I plus j and plus 4k, this whole stuff divided by root 18. So this whole stuff is a vector whose magnitude is that of same as that of vector A and direction is same as that of B, provided this is A and this is B, fine. This is nothing but direction of B, magnitude of A. If you are asked to compute a vector whose magnitude is same as that of vector B and direction that of A, then this is the way. Magnitude of B, direction of B. Compute the magnitude of B and multiply with unit vector of A, you will get direction of A, magnitude of B. Suppose you are asked to compute a vector whose direction is same as that of A and magnitude 25. Magnitude 25, direction that of A means 25 A cap. So this particular vector C will be 25 A cap, means direction of A, magnitude 25. Clear? Suppose you are asked to compute a vector whose magnitude is 10 and direction same as that of vector B, then this is going to be vector D, 10 B cap. B cap means direction of B, magnitude 10. It's so simple. Clear? Direction of A, magnitude of B. Magnitude of A, direction of B. Okay, this particular vector, magnitude of A, direction of B, direction of A, magnitude of B, magnitude 10, direction of B, magnitude 25, direction of A. Okay, so simple. But somehow these two vectors are mutually perpendicular because their dot product is 0. Clear?